Thank you very much indeed. Well, my name is Rainer Seidel. I'm from the University of Auckland, so I'm not from industry, but I work closely with industry. As you may be able to hear from my accent, I'm originally from Germany. About a quarter of a century ago, I immigrated to New Zealand, and I've been working with the University of Auckland since then. The paper that I'm presenting today is about a course that we have developed over a period of 5 years, and this course is in close relationship with industry, following the CDIO principle. So what is it all about? Here, the course is called Advanced Innovation and New Product Development, and it's a final year and postgraduate elective course for engineering students, but also for students from other disciplines. So we have got students there that are who are engineers, but we are also dealing with students from science, from law, from other faculties in the University of Auckland. Some time ago, I realized that there is something deficient with the way that we are educating our engineering graduates. I got this information from talking to people from industry. Here's a typical, on the left-hand side, a typical statement that I got from an industry manager. What this person says is that our engineering graduates, they are good, you know, they understand engineering, they understand the theory, but they haven't got a clue about the reality of how this works in practice. And this is where this course comes into. Now, we are advertising this course to our students, to our final year students in the engineering faculty under those issues. Is for those people who are interested in a real-life project experience, in industry-based project work, experiential learning, in a multidisciplinary experience, in teamwork, and of course the course is in new product development and in business innovation, which are both critical issues for the small and medium-sized companies that are predominant in the New Zealand economy. So, what is this course all about? Well, it's a very, very complex course. And unfortunately, in the 15 minutes that I've got here for presentation, I can only concentrate on a small number of core issues and core features of the course. Here, this is a page copied out of the course brochure that we distribute to our students. The issues covered in the course, you see them all here, and there are many of them. The course, the task for the students is simply develop the concept for an innovative new product for your host company. That's how we start off the students. And the issues, the features that we are covering is sharing ideas, multiple perspectives. There are points like communicating, design facilitation, optimizing, making an innovation profit, using analytical methods, visual communication, models of innovation. These are all issues in some way covered in the course. Not necessarily taught, but they are being taught across through the project works that the students are being thrown into. Now, in the course, we try to achieve that students learn for understanding. They are not supposed to learn theory, they are supposed to pick up what's important about their work in an industry context, and in particular in the context of new product development design. In other words, working in a multidisciplinary design team in industrial practice. Now, the features that support these, some of the main features are project-based learning, of course. You can't learn doing new product development by studying a textbook. You have to work in a project. You have to work with a real partner in order to make it realistic. So we have fostered very strong industry partnerships. It has to be multidisciplinary because new product development is multidisciplinary. You have got engineering design, but you also have got the aesthetic, creative design. You have got ergonomics, you have got cost factors, you have got marketing considerations. And in innovative new products, all of these elements have to come together. And it can't be that engineers, mechanical engineers, for example, work in isolation on their detailed design development. They have to be able to communicate with the other colleagues from other disciplines. That's why we are also inviting students from other faculties to participate in the course, work together in those multidisciplinary teams that we create in the course. Communication and teamwork, I've just mentioned, this is critically important in an environment, in a dynamic new product development environment. Feedback and assessment is a very critical issue for learning. Feedback is very important for students to really understand how they are doing. And assessment is a very, very strong motivator for people, for students to pick up the right ideas. So I'm going to talk a little bit about this. Another feature that we've built in the course is the so-called reflections on learning, which foster closed-loop learning and really a sort of an externalization of the tacit knowledge that the students have developed through the project. And then we have other things which I don't cover in this presentation because time doesn't allow for it, like studio sessions. Because a lot of the learning in new product development or understanding in new product development has something to do with kinesthetic things, with touching things, with building prototypes, with dismantling an existing product and things like that. And you can't do that probably in a classroom, so we have got studio sessions in there. We also use studio sessions for fostering, for example, communication and making people understand their roles in a multidisciplinary team, which is a very, very important issue. So let's go a little bit more into detail into project-based learning. Now, the emphasis that our emphasis is on generating and applying new knowledge in a meaningful, realistic concept, CDIO. Really meaningful, realistic. It must make sense. Working on a real project, a real problem, with an industry partner as a client. So it's not something that's made up for classroom experience. It is something real that students are, if students are doing well, this idea that they develop, the product concept, will be developed further by the client and put into the marketplace eventually as a new product. Application of the iteration principle, that's something that's quite foreign to traditional education. When you think about it, how we educate our students, we tell them what they need to do. They hand in an assignment or they write a test or an examination, they get assessed, they get a mark, and then they move on to the next topic. In industry, it doesn't work like that. If you have got a new product in development, you know, you don't put it into the marketplace, into the market before it's refined, before it's iterated. And sometimes there are dozens, hundreds of iteration cycles. Our students generally don't understand this. So we emphasize this as well. We, as mentors, as core staff, and our external collaborators from industry, we see ourselves as mentors. And of course, the assessment structure, as I said, is very strongly related to the course objectives, to the learning objectives that we see for our students. Oh, the time is running fast. These are a few examples of industry clients: a furniture company, a company that's building bathroom equipment, another company that's marketing GPS systems and fish finders and things like that. And here is a company that builds tow cars. So these are 4 of the clients industry clients that we've worked with so far. Now this is the project structure. Okay, 4 cycles, a 12-week semester. First 3 weeks, idea generation. So we don't tell students, hey, develop this type of product for that company. But we tell them, hey, this is the company. Think about a product you can develop for them. So it's not just problem solving, also problem finding. And then we have got 3 iterations that students go through. So they have to make 3 submissions of their intermediate results. The final submission, also a PowerPoint presentation and a presentation to the client. In between we have reflections teamwork, and a final project and reflections on learning at the end. I mentioned this for deep learning, for closed loop learning, reconsidering what was happening in the project. Here, the 4 C's, iteration, principle very closely related to the Deming cycle. This is something that we ask students to do within each iteration of the project. They go through this 4C loop a number of times, at least once, but generally a number of times. So they try to understand what the issue is. They create a solution. In other words, they design something. They look at it and they critique it. They try to figure out whether it's actually doing what they have understood it should be doing. And then they communicate, either within the group or an assessment to the course mentors, course staff. Assessment structure. Very critical. A small minority of students are internally driven. They do that stuff because they like to do it, you know, and they like to do their best, and they do the best thing, and they figure out intuitively what kind of issues they need to deal with. But the majority of the students, they have to be brought to a point where through the assessment they are guided into learning the right stuff. Now the first bullet point here, this is a traditional assessment of projects, right? I mean, you assess the project on the basis of tangible progress and outcomes, something that you can look at, that you can measure, quite clear. Second kind of assessment, what we realized in the early stages is that some students really don't get it that some of the stuff that we are presenting to themselves is important. So we ask them to write something about it, to draw their ideas about it. So that makes them being alert during the presentations, during the studio sessions. The last part, I've talked about this already, these are the reflections. That's then external, the whole knowledge, going through it again, thinking deeply about it, closed loop learning. Now when you look at it, it's quite an elaborate assessment schedule. But I have to say it's closely monitored, so we make sure that students aren't overloaded. And also, I mean, one issue is somebody needs to look at it. Somebody has to make the assessment. So we make sure that we don't overload ourselves as well. And that's why it's very elaborated. I mean, it's very clear instructions how much they have to submit. For example, this is just a paragraph. This is an assessment. This workbook is a short report, couple of pages or something like that. Right. Course website. Very important communication and assessment tool. I mean, we have developed a website over a period of 4 years, and it does everything that we think needs to be done. It acts as a communication interface. It acts as a repository for course information. In particular, it's the marking and assessment tool. You see here, this is the page for blog submission. That blog submission up here is the start of it. It's probably another 5 or 6 lines or so. If you click on that button, a few drawing in there, and this is my comment that I gave at the end. This comment is readable by the student. On the right-hand side is my mark. 3.75 out of 4, a pretty high mark, okay? So this is that one thing. In the next page, next slide, this is a more elaborate kind of submission page for the first submission, the team submission, the idea presentation. Now the idea presentation is submitted, you see, in PowerPoint format, and it's submitted to this team of students, a multidisciplinary team. There are, from memory, 2 commerce students, there is 1 science student. This person is an overseas student, 2 engineers, 2 commerce, 1 science. And here is a communication thread that is readable by the students. And over here on the right-hand side, again, the marking sections with comment. Now, there are different people involved in the mark, in the assessment, and in the end, the course organizer, that is myself, I give the final mark, which is then visible to the students. This is that. Reflections on learning. I talked about this before. This is one of the core points in our course. This is so important because in that short period of 12 weeks in a semester, there is so much happening in that project. There are team issues, there is communication stuff, there is the technical development, there is the learning of the new product development process, there is learning to communicate across disciplines, so picking up information from marketing or from aesthetic design for engineers and stuff like that. And it's very difficult for students to digest without sitting back at the end and thinking about it. So this is what we are doing. That's what we're asking students to do. Very open-ended, but we give them something like clues like these 3 bullet points. That's the kind of stuff that we're expecting of you. And I think that's the last slide. No, the second of last. It's very beneficial what we are doing here, but what I wanted to show you in particular in that slide is that's what students say about this. I've learned more from assessments and my team members than I ever could have from reading a textbook on the subject of new development. I'm glad that I took this course because it helped me to integrate all the skills I've acquired and made me better prepared in the working world. And here, this is a particular important one, a particular interesting one for me, because this person realizes there is something that he learned there that will help him through the rest of his professional life. But, I mean, I picked out those 2, but basically all of the reflections on learning have got profound statements like that. Well, that brings me to the end of my presentation. Sorry that I had to rush through it. Thank you for your attendance. Questions?